The audio will get Sorry. Hello, hello. That is an update. That yes. So every time I have to disconnect the audio, it used to be a default. Maybe it is a default configuration. I can find. Sorry. Hello. So hello. So Annie, you can hear me, yes? Or
Yes,
yes,
I
and you
can.
could hear me twice a minute ago. Okay. Great. Thank you. Hello, Annie. Hello, Gabriel. Hello, Jocelyn. Now I'm
Your
doing.
share screen, your share screen sharing your screen.
Oh God. Thank you. You're absolutely right. Yes. See. Okay. I have to re. Yes. Thank you. Right. Okay. One second. One second. And who, sorry, and who, I'm still saying hello, but who just told me that? Who just told me the screen sharing was weird?
Me.
Melanie, okay, thank you. So you could definitely submit that for whatever, for voice, for correcting the professor, whatever. Great, thank you. All right. So I said hello, Annie. I said hello, Gabriel. I said hello, Jocelyn. I'm doing the chat. Hello, Vicky. Hello, Jocelyn. Hello, Vanita. Hello, Jean. Hello, Vincent. Okay, okay. Tell me if I said your name wrong or et cetera, et cetera. Okay, so we're gonna get rolling here. So I think we can roll more and more now. We can like really start getting into physics. Quickly. Yeah, hopefully, many of you have already submitted homework one, gotten some points. Then many of you have resubmitted homework one. Many of you, or some of you have gotten like all the points now. Maybe with some of you, there's still a couple more points you could get, but again, you don't have to. It's just you can. But I mean, if you've submitted revision already, that's great. And probably, I'm happy as long as you know what to do for the future. I'm happy to move on if you are. That's in terms of homework, but we're going to still, I'm talking fast because I always do. Homework one, we're still going to talk about the physics of it today. Like we never really talked about the hard exercises at the end, but I think everybody's with me, it looks like, in terms of doing the work and getting the points. More and more as we proceed forward, when I look at your homeworks or whatever, more and more I'm just going to write things like, and your exams, it'll just be like step one or DFP. Like more and more, I'm going to expect that you know what that means. It might not mean it's missing. Like if I say in the future, step one, DFP, you don't think, wait, I have a diagram right there. What's he saying? If you have it, it means I'm still saying you're still not totally getting right how to do that step. Quick example. Some of you are putting graphs in for the very first for your diagram for a question. The graphs are impressive. In many of your cases, the graphs you're putting in really do show that you're smart and you know something, and maybe you rocked high school physics. Like many of your graphs are correct, but that's not really what we're looking for in step one. We're looking for the facts of the actual situation. Believe me, we're going to get into the graphs and all that, and you'll need them. So it's not, but so often if I put a step that's saying, wait, or, better example in many of your cases, better example, if I write in the future, step two, WIQ, that maybe doesn't mean you don't have the question there, but it might mean in many of your cases that you just copy and pasted my question, or more subtly, you like wrote out the question, but in the same exact words as I did. That's not the point. I'm not trying to give you busy work. You'll see it becomes really valuable later on. So, and stop me at any moment, but that's the point, is from generally speaking, the feedback is going to get more abbreviated. But certainly, have I said hello? But certainly at any time, you can always ask in class. I talk fast so I can get in everything I'm trying to say. It's not to discourage you from stopping me. Just to be,
I have a question,
yes, yeah.
Professor. So, I'm looking at my submission for homework one, and you said that you left some comments in the document. Um, I cannot like see like what you wrote or what you
I
typed.
agree. All I see is
Yes,
yellow highlights.
yes.
Yeah,
Okay.
it's the yellow highlight.
Yes, this is a very good point. I'm glad you raised this. Yes, I couldn't remember one of the sections. This already came up. I got yes. Thank you. Absolutely good point. Okay, let me slow down for a second. Really important. And thank you for looking. Right. So if I said like see in doc comments, and especially if you see yellow highlight, but you can't see the actual comments, what this, they're there, but but you're not crazy. It's a really good question. What what this unfortunately means, this is one glitch I'm still a little bit concerned about Google Classroom. I don't know how I never realized this in the past. What this means, unfortunately, if that's the case, you have to actually like exit out of Google Class or whatever, open up a new window. You could keep the Google Classroom going, but if you just open up a new tab, I mean, in Google, open up a new tab, go directly to Google Docs. And I'm going to give you, like, do this right now. Like those of you who are asking, like, try this right now. Make sure I'm not crazy. Go to Google Docs, open in Google Docs, open the most recent version of your document. You should see it there. It might be called edited. I'm not sure, but you should see your most recent version of your document there, and there you'll see the comments. And I know that's stupid, and I'm still trying to figure if there's, I'm not sure if it's specific to certain type of documents and you hand in or certain ways that I'm doing it, but I believe that's the case. Tell me is it working, Annie or Melanie? Are you seeing what I'm saying?
When I open it in a Google Doc, it's
It's
just
blank.
like a transcript of my writing. Like, I don't know how to describe it. Do you want me to like
No,
screenshot
I do know the
some?
thing you're talking. I mean, you can, and you'll get points if you want to. You can, but I think I do know. But are you sure if?
Mine is blank if I open it in Google Docs. Like I have the title for homework number 1, but it's blank.
Okay, wait. So somehow, and I know that. Okay, this is a very legitimate question, and for sure, if I'm going to make these comments, of course, I want you to see them. Now, there is a comment in the chat right now from Vicky, which I totally appreciate. Um, First of all, Vicky should definitely give herself points for that. I mean, but right, it seems to be different things for different people. Try Vicky's thing, number one. But number two, we're going to get this right. Like, if it even means that I have to start doing things a different way, I will. I feel like maybe, I know they're there somewhere. Wait. So so you just open, and you're sure that when you're going into Google Docs, are you do? And I also know we should only, I promise, even if we don't get this resolved for everybody right now, I've been tasking this, like this came up in the other section too. I'm working on this. So, and at worst, like later on, if someone sends me a personal, if you still can't find yours, send me a personal email or with screenshots or whatever, and we'll try to work on the personal situations one by one, because for sure I want you to see these comments. Yeah, I mean, um, um, but there's Vicky. So Vicky. Really? Oh my God. Wait, that actually. So that solved. Wait a minute. You click onto. It's not working. Okay, so it's clearly not working for everybody, but I'm glad it's working for some people. And believe me, you might even notice. Oh, it might be in the other section. I'm a student now in at least one of these sections. Like I made a student file, and like I'm trying to go back and forth and see exactly what it looks like So I'm not giving up on this issue. So I'm glad this is but clearly somehow it's a case by case basis. Wait, I see it's not working for everybody. I just want to see what exactly. And I will also say it may be device related. Like for the people it's not working for yet, for sure, I would say, like if you're on a iOS or if you're on like a tablet, you might want to try on your actual laptop, blah blah. But okay, it's working for enough people. Those of you who it's not working for, I totally hear you. I see you in direct chat. It is important. Please just like bear with me, and later on or tonight or something, send me a screenshot or something, and we'll try to figure and give me detailed. If it's still not working, give me detailed, like I'm on this kind of device and I did this and blah, and we'll it also may be, yeah, let me just say that for the moment, but definitely a legitimate question. Just remind me later if it's still not working for you. And at worst, if we get to, anyway, okay, but good question. What else was, okay, so I'm gonna go on to the homework. But yeah, what I'm about to do, there's one other thing. So homework 1, we're gonna still finish talking about, and so I can give you the actual definitions, like the concepts that we're starting to roll with now, and they're gonna turn into equations. Like we want to get into equation land now, right? And that's what starts being relevant for homework 2 and homework 4, etc. But there was a little confusion about homework 2 and 3. So homework 2, was technically supposed to be due today. I think in one of the sections I accidentally made it due Wednesday. It was supposed to be due today. But no matter what, and I think a lot of you, I think most of you did it or tried. We're not going to finish going over it today. It's fine. The same thing as before. Just wherever you are with it, just keep up with it. Or if you already got points, revise it, whatever. We're going to start talking about homework 2 today. But to be 100% clear, homework 3, which is the next one, homework 3 is like a little bit of a left turn. It's kind of different. It's more conceptual. It's more creative, fun. It sets a stage for not homework 2 and 4, etc. are about equations, getting us into equations, but homework 3 is about the concepts behind the equations. So long story short, homework 3 is the next thing to do, but with homework 3, I don't remember if I said this in the class, you don't have to stress about 5-step method in homework 3. Exactly. It's like but you do still same format, like present me separate sheets, show me what the question is each time, draw diagrams where it says to, like still give me a document that I can follow in and of itself. But I will tell you with homework 3, since it's more creative and fun or conceptual, as long as you do it and you sort of thoroughly, clearly do it on separate sheets and make it clear what you're doing when you're doing it, you're going to get all the points for homework 3. Like, don't overstress homework 3. And then it becomes a discussion topic. All right. So I hope that's clear. I hope I'm making sense. Okay, I'm just looking at the chat. So what I want to do now is sort of just keep proceeding a little bit more carefully with homework 1 and homework 2. I believe, but last thing, I don't remember if it was the other, I think in homework 1, yeah, we're going to start going back over to homework 1 now. Number 1, I think the answers that I scrawled out at the end of class last Wednesday, I uploaded them as a PDF. But I believe before I corrected the PDF, I believe maybe in your class, my very last answer, the answer I gave you, I believe I said average velocity equals positive 3 feet per second for one of the very last answers, but it should have been -3. I believe it's corrected in the PDF that I uploaded, but just note that, especially if you were confused by that, I believe that last answer I wrote down for you, I wrote +3, but I should have written -3. Let me know if that makes sense. So what I want to say now, if that's okay, I'm about to pause. We're going to go on. I would now like to answer any questions that anybody has about like I'm not going to walk through each question. It's going to take too long. Oh, wait, there's something in the direct chat. Okay, hang on one second. Hold on one second. One second. Okay, yeah, I'll say quickly because there's a couple of things in the direct chat, just quickly overview. Yeah, anywhere in the homework, if I write something like GDP or PAW, I'm referring to one of the steps of the 5-step method, which is that sheet in tools of the Google Classroom. Like it says a brief outline of those 5 steps, and it says what those 3 letters stand for. That's like the brief explanation of the roadmap of the 5-step method. But if you want the fuller explanation, all of you, any of you, of exactly what the 5 steps are, watch the last class video, the video of the last class last Wednesday. Because again, And you can always nobody's gonna be embarrassed about wanting to get more explanation from that from me in private. Like, I'm not saying I'm never gonna say it again just because I said it once. But as far as the whole class is concerned, I feel that I walked through that in the last class. So please rewatch that video and or look at the sheet and or make a private appointment with me. Because bottom line, yes, for all of you, from here on in, those 5 steps are how you do all your work, and they're how I grade your work. Like, yes, including exams. So it's good to know if you're confused at all. Don't be ashamed. Don't be worried. I will re-explain it in private. I'm just not going to like fully re-explain it in class. Okay. No, yeah, totally. Okay, great. Thank you. Private chat people, and please submit points for closing the conversation loop. Got it. Got it. Okay. So I want to go on, but here's my 2 options for you guys. I don't want to walk through every single one of the exercises in sheet 1, because I think a lot of you found most of them fairly straightforward. We're going to get to the meat of the issues when we get to the hard problems right at the end. So I'm not going to walk through all the beginning ones. I'm going to go straight to the end. However, if anybody has any question at all about any of the questions in homework 1, number line, and no question is too dumb or too easy, whatever. Any question of confusion at all about like how I got answers for any of the answers I gave you, please, like, I'm going to pause for a second, give you time to think. I want you to ask them now. Like, no shame. It's faster to do it by your questions than for me to walk through. So if there's any questions on how I got any of the answers to homework 1 up that I presented last week, that this is the time. And I'm going to literally pause for a second to make sure. In fact, I want you to rate. Oh, yeah, go. Yes, Annie. Sorry. Yeah, go.
So Professor, so if I scored like well on the first homework and it's like mostly about the 5-step methods, can I submit that document to user manual, the 5-step method for solving problems? You know, that game submission?
Yeah. Oh, yeah. Didn't see that one coming. I believe, yeah, if you're saying you scored well and it was clear that you scored well because you like did a good job of using those steps and making those steps clear, that's what you're saying? Yeah. Yes. If your steps were good and clearly, and they were clear, and I said they were good, yes, that's a great, then yes, you can double dip. I'm glad yes, you can double dip that into the game assignment called 5-step method. Great question. Wait, first of all, is my answer clear? Like, is that clear?
No, yeah, it's good. Yeah.
Okay. So
Thank you.
great question. No, thank you. So, and that applies to everybody too. Like, she's right. Like, once you feel that you get the 5-step method, once you feel you've gotten it right, like either right on any of your homeworks or on a fictional, then yes, you can double dip that homework, double dip into the portal, into the game portal that asks for good examples, clear examples of 5. And just think of it like there were more than one person. No one should be embarrassed. There was more than one person in direct chat sort of asking still about the steps. We get used to them over time. So think of it. Any one of you who didn't get it at first and gets it now, just think like the more examples I can collect from you to show your classmates, this is what I mean. Like, this is what it would be for your colleague to do this. Is like good for everybody. So yes, once you think you've nailed it, you double dip that into the game portal so that I can use that examples to give to other people if I'm working in private with them. Absolutely. And last point about that, if I ever return any game participation thing to anybody of any kind, and I write double dip underneath or triple dip, that's my way of saying to you, I bet there's another portal this also applies to. I'm encouraging you to take the exact same document and put it in another portal too, like for sure. Yes. So great question. Again, all of this is good to know because I'm going to, the work is going to pile up for you and me. So the more I can just abbreviate my responses to you people, and the more they're clear, the better for everybody. Okay. So I'm going to pause for a second. I'm going to ask, is it clear? I'm going to pause right now for you to check if you have any confusions or concerns or questions about any of how I got the answers to the physics of homework 1, any of the answers that I wrote down, like not the last 2 parts. I'm going to talk about the last 2 parts, but any of the ones I wrote down. Right now is the time to see, do you think you understand the physics, specifically distance versus displacement, average speed versus average velocity? Like, so now I'm not focusing on the steps right now. I'm just focusing on physics. So raise your hand if it's clear. That's what I'm looking for. Raise your hand if it's clear that I'm asking. Oh, okay. Well, Gabriel, thank you. Annie, okay. All right. But anybody else, are you clear that that this is the time to ask?
Where's the document that you posted of the homework? Or is it the video from the website?
Wait. Good question. It was the PDF. Well, I'll show you it. Right when we ended class last time, I posted a PDF. Oh, it's called Class Notes 2, I believe. If you go under Class Notes of Google Classroom, so every day I'll post whatever like this board thing. And I believe our very last class was class number 2. So Class Notes 2 is a PDF. I believe the last page of it or the last 2 pages of it are where I wrote down the answers. I believe, and maybe somebody else can confirm, and that would count for points too. But I believe that's where in fact, maybe I could find it right now. But yeah, so you
I
just,
see it.
oh, okay, great. So just take a moment to check for a moment that you're okay with my answers, like how I got the distances or this displacement, like, and if we're okay, then I'm going to move on to the hard questions at the end, and that will be my way of talking about concepts. So I'm going to pause for a second. In fact. Looking in the chat. Okay, there's nothing in the chat. Okay, I'm gonna start drawing and start preparing like the last two, but but you could still keep looking if there's questions. Hold on a second.
Quick questions
Yeah.
for one of the questions where you got -3 feet. How is it negative?
Oh, great. Okay, good question. So are you talking about, for example,
Yes. I
oh,
believe that's example 5. Is it 5? Yeah.
wait, if it's
No,
fun,
6. Is it 6?
I think maybe
Hold on.
it's, yeah, maybe look for a sec. Okay.
Yeah, it's 6. No, it's 5. I'm sorry. Example 5.
Well, okay, we're
Or is
actually,
it?
okay. So, no, good question. I'm glad you're asking. Wait, and also I'm back and forth between screens. So sorry, well, it doesn't matter, but is it Melanie? I can't, I'm between screens. Is it Melanie? I mean, it doesn't matter. I'm
Yes.
talking. Okay, great, Melanie. Okay, good question. So I think it's example 6, not example 5. I'm gonna try to say this without drawing because I'm not gonna mess up well, actually, okay, here's the point. Speed at,
Uh,
did you just figure it out? Did you just say, oh?
I didn't. Okay, I see what I did. I just left that as a fraction. I didn't divide it again to get a whole number. That's what I did. I did -9/3. I didn't divide it again, if you get what I'm saying.
Oh, oh, okay, sure,
Yeah.
sure. So I would do, but okay, fine. But so in other words, you're not concerned about the negative, you're not confused by the negative sign. You have -9/3 and I have -3 over.
Right. And I
Oh,
saw that you just divided it again. Okay. I see my
okay.
problem.
Oh, okay, great. Good talk. Good talk. All right. All right, awesome. Um, okay, then I'm gonna go, okay, I'm gonna quickly, okay. So I'm gonna quickly do this. Bear with me for a second. Sorry. Um, Okay. Um, okay, so here's my rough quick diagram. Notice this diagram again is like a slightly different version of whatever. This is my diagram. Notice my fact pattern. I'm making my big point that I think is relevant now to these problems is that each one of those segments, like it gave you a distance for each segment, right? And it gave you a time for each segment. But please notice also that it said that each segment is constant speed or constant velocity. Each one of those, and that's actually vital information for what we're about to do. So there's my diagram, right? That's all step one. Sorry. Okay. So now the question, so I'm doing question one. At t equals 7, x equals. Oh, and right, I believe that's question two. I'm going to do a quick side, right? That's question two. Is at the 7th second, what is the position? I want to do a quick sidebar for you now. Like this is an instructor sidebar in terms of notation, since we're getting into equations and notations and everything. So I'm saying when I say this is instructor sidebar, I mean like I wouldn't expect you to put this into your homework, but I do absolutely want you to know this. Okay, I imagine it's not, I know it's not, I think it's clear to you guys that like I'm using lowercase t to stand for time, and I'm gonna from now on use X or Y or Z, but to stand for space. Okay, I don't think that's surprising to most of you, but let's get a couple of details clear about that. Like all of physics is about stuff in space and time. From here on in space and time are two fundamental variables, the two things that will change throughout, the two values that will change throughout experiments or theoretical problems, right? Like the value of space and the value of time. Like that, and that's what we're always measuring in physics is where something is when. Like literally, that's all there is to physics is stuff in space and time. So let's take a moment to be clear about space and time. From here on, right now, this chapter of physics, if you were to look this up in a book or Khan Academy or anything like that, what we're talking about right now, what the chapter that we're doing, the unit we're doing is called one-dimensional kinematics. Kinematics means motion, but all of physics is about motion through space and time. Specifically, kinematics means the definitions for motion. Right now, we are defining our terms for studying motion. Okay, and specifically, we're looking at motion right now in one dimension of space. Like, I want to be explicit about that. This whole number line problem is like a fake, silly problem, whatever, but it's trying to establish that the first unit or the first chapter, the first topic of physics is defining our terms for what it means for a particle, a mass, an object to have freedom to move within one dimension of space, i.e., forward and backward along a number line, or north and south along a number line, or left and right along a number line, whatever. We have one degree of freedom. We have two possible directions that we ultimately call positive and negative. We are in one dimension of space. We're in one dimension of time. So, and since there's only one dimension of space, we call it X. Like maybe later on, when there's two dimensions of space, maybe we'll call them X and Y or whatever. But so right now, space is X, time is T. Now, here's the subtlety that is not, well, the two subtleties, they're not obvious, maybe, unless I say them. One is, notice that I'm using triple equal signs. I think I said this last time. It's whenever I use a triple equal sign, I'm defining something. You're like, I'm not discovering it in a lab. I'm establishing it with language. When I write X from here on in, I mean the value of the space variable at one point in space, which in English we call a position. X has a value, like it's 4 or it's 3 or it's 7 or it's whatever. It's a dot. It's a dot in the number line in the x-axis of space. Okay, so it's a position. Similarly, from now on, when we say T for time, we mean the value of, we mean where we are in the, or when we are in the axis of time. We mean an instant from now on. As opposed to, so this is why as opposed to, if we're starting to convert our English into symbols, right? As opposed to, this is still the instructor sidebar here. As opposed to, I'm sorry, well, not as opposed to, but if from now on, I want to refer to a special, if I write X naught, what I mean by that, I'm sorry, if I write X subscript 0, that's read out loud, that's said X naught, N-A-U-G-H-T, or sometimes N-O-U-G-H-T. It's like a British thing. It means nothing. Naught means nothing. So if I say X nothing, X naught, that's how you read that symbol. And what it literally means, what it's defined to be, is the value of X at T equals 0. Okay? i.e., X naught from now on is still a position, but it's a particular position. It's the position at the beginning of an experiment, or at the beginning of an observation, or at the beginning of a theoretical problem interval like we have for homework. So if from now on you see that X naught, it means the first position in some segment you're paying attention to. It's like, yeah, it's the value of X when the value of T is 0. Now, let me be more specific. So, I mean, of course, I know many of you know this from high school, but some of you don't. Or maybe it was used all the time in high school and it was never clear. I don't know, but I just want to be clear about it. Similarly, and of course, you can stop me and ask questions, but similarly, if from now on, I put any variable down and I put the 0 subscript next to it, like squiggly just means like any variable, any general, like V for velocity or F for force, whatever. If I do that from now on, that means the initial value of whatever that variable is. So this is going to be a universal thing that we do in physics from now on. And again, squiggly just means any variable. Stop me if it's not making sense. So to be really specific before I go any further. So when I say X naught, that doesn't necessarily equal 0. Like in this problem, in this homework, like X naught, it doesn't equal 0. In this homework, X naught equals positive 4, right? Because that's where the guy is at time equals 0. A little bit more subtlety on this. If I'm saying from now on, and I can go back at any time, if anybody ever asks me to go back, first of all, I will. Second of all, you get points for asking. But if you don't, I'm going on. So if I'm really saying that any variable sub-zero means the value of that variable at 0. That means variable sub-zero, variable naught doesn't have to be 0. It's the value of it at time equals 0. But so then let's get this straight. T would be value of t at t equals 0, right? So that would be, so that would be 0, like, right? Like x sub 0 doesn't have to be 0. It could be 4. But t at t equals 0 by definition does have to be 0. So what does that mean? What does it mean for time, the value of time to be 0? It does not mean the Big Bang or the Garden of Eden. Like, it doesn't mean the beginning of time. It means when the time started on the particular experiment or the particular problem, i.e., it means when the observer, when the physicist, when the researcher started paying attention. Like, more concretely, it means when we start our stopwatch for this particular situation. That's very important. So it can change throughout your calculations. Like, you could start paying attention at the beginning of a whole experiment over here, and then as you're zeroing in and zooming into a particular piece of an experiment, maybe you're just worried about that piece or that interval of the experiment. So you start like paying attention. In other words, depending on our calculations, we might end up focusing on the 7th second of this whole thing as t equals 0. We can recenter our perspective. That's like the bottom line of what I'm trying to say right now, and stop me if it doesn't make sense. All this having been said, then I'm still in the sidebar and then I'll go back. Then from here on in, from okay, what I'm just all this is trying to say, in the end of the day, X stands for a position, but X minus X naught for some interval, wherever, once you're focusing in, some interval of some experiment, X minus X naught is the difference, the segment between two positions, the final and the initial. So that's what we would mean ultimately by displacement. Like, what I'm really trying to say secretly is distance and average speed are those scalar quantities, distance and average speed. Those are important quantities. Those are important measurements. They're important concepts that we have in our mind that hopefully like we understand in English, distance and average speed. But we use those concepts to build the more precise physics concepts, the more precise physics vector quantities that have not only size but direction. We build from distance displacement, and we build from the concept of average speed, average velocity. Once we're at displacement and average velocity, then we're talking about things we really care about in physics. So we start notating them with symbols and equations to start abbreviating our whole discussion, right? So from here on in, X is position, but X minus X naught is displacement. X minus X naught, right, is displacement, final position, any random position you're looking at, minus the earlier position for that interval. So finally,
Wait, quick question. So X naught is, so X subscript 0 is represented by X naught, meaning that at any position given, so whether if you're given like 3, 4, that would be your X naught or something.
I think, okay, good question. I'm glad you're stopping. And again, no, I think that is, oh, yes, good question. Let me back up. I think this is what we're trying to say. X, just like X itself, regular X, would be any given position you're looking at, like where the guy is at some moment of time that someone specifies. Like at time equals 3, what's X? Or at time equals 7, what's X? So X is like any random position. But he got there somehow, presumably. So X naught means the very first position of whatever interval you're paying attention to. X naught, X sub 0, would be the position that the thing was originally, initially, when you first started paying attention. So I'm really saying, in a way, like X naught is the special, it has a special designation because it's wherever an object was when the clock started. And then X is wherever the object is, like now, when you like, so X naught is like the original position, and X is the current position, the position now. So let me put it, what this might confuse you less. Like I'm saying, hold on. I'm saying this equals, I'm saying the difference between where something was and where it is now is what we call displacement. But in a lot of textbooks or videos online or Khan Academy or something, a lot of people will say something like this, and this is fine too. You could write it like this if you wanted. Or even like this. All of these are legitimate equivalent ways of saying it. I'm basically, in the end of the day, saying displacement is the difference between two places, a place that you were and a place that you are. So you could even just think of it as like X number 2 minus X number 1, or X final minus X initial. And maybe in high school you had equations like that. I'm saying at the end of the day, the way physicists really tend to really write it is they just say any random X minus the original X. But if any of these make sense to you, they're all saying the same thing. Does that clarify it all?
And it clarifies it.
Okay, cool. Great question. Okay, awesome. So therefore, to everybody, in the final analysis, I'm saying, oh, sorry. I'm also going to say, I'm also going to say from now on, if you have any symbol that stands for anything, like V stands for the word velocity, or if you have like A stands for acceleration or something, from now on in physics, if you put a bar over the letter or over the symbol, what you mean is the average value of that symbol. So from now on, we're going to say V with a bar over it stands for average velocity. I know I haven't even defined, like, I don't know what that means yet, but I'm just saying if V stands for velocity, then V with a bar stands for average velocity. And in fact, from now on, if I ever put a bar over any symbol, then it means the average value of that symbol. Now, so I'm saying that. Now you might say, wait, well, what is even velocity? Good question. I'm about to tell you, but be clear. And this came up in some of your homeworks. Like, I'm about to tell you what I mean by velocity, but specifically, I'm about to tell you what I mean by average velocity. Be aware, velocity itself, like, well, I'll tell you what I mean. So I'm saying, let me be as clear as I can. I'm trying to relate this all back to the homework. I'm going to go back and solve those last homework problems with this, but I want to be explicit for a couple of, I'm saying here's our first equation, and there's our first real equation. I'm not saying it's hard or trying to make it dramatic, but it is our first actual equation. Of course, physics becomes all about equations, like very quickly. Our first equation is V bar triple equal sign x minus x naught over t. Now, what that means in English, or what that's saying in English, is average velocity is defined to be displacement over time. Let me be more specific. Like for any given experiment you look at, or any given theoretical phenomenon that you look at, if it's physics, something is moving through space and time. Like literally, I'm not exaggerating. All physics ever is, no matter how complicated physics gets or seems to get. Doesn't matter if we're talking about electrons or planets or whatever. What physics is about is stuff moving through space and time. And let me make that even more clear. That's not an exaggeration, and that's not a simplification either. And it's not a condescension. Like, think about your units from chemistry or from 7th grade or whatever. The unit system, the SI system, is often known as MKS, right? Meters, kilograms, seconds. Just those three. Everything is built on those three for a reason. That all that's ever happening on a fundamental level is that some amount of kilograms are moving through some amount of meters through some amount of seconds. All there is to look at is stuff going through space and time. So if we examine, so if we examine some interval of space and time, and something, and a particle or a professor or an object or a planet or is a mass is moving through space and time, average velocity is just a definition we come up with. It's just an abbreviation for the simplest possible ratio, the simplest possible quantitative relationship between the chunk of space to the chunk of time, right? That's what velocity is. It's a rate of how much space something traverses per how much time, right? I mean, when I'm not saying it's easy, but I'm saying it's simple. What average velocity is just the ratio of how far did you get in how much time, right? Like measured in, like, if you traveled 30 miles in an hour, then your average velocity for that interval is 30 miles per hour. So it's abbreviated x minus x naught. So it's just, if you look at the yellow version of this equation, we're inventing something here. I want to make it clear again. We didn't discover this in a lab, and we can't undiscover it in a lab. It's perfectly true because it's just an abbreviation. We're saying if you ever divide the ratio of space by the ratio of time, so it's just x minus x naught over t minus t naught, you get this thing that we think is meaningful and relevant, and we call it the average velocity. But notice, since t, so it's a perfect ratio, like balance between the two, but t sub 0 is always actually 0 by definition. So the equation simplifies a little bit, right? From here on in, whenever I think of v with a bar over it, I'm thinking, how far did I get per how much time? From whenever I was first looking to whenever I stopped looking, okay? So that's an equation, but the two things I'm trying to get across, and it's our only equation so far. So I mean, the three things I'm trying to get across. One, it's the definition of average velocity. This doesn't tell you what velocity at a moment is. It tells you what velocity on average is for an interval between two moments. If you're totally with me and you're starting to get bored, or you're taking good, really like sidebar notes, you might want to make a note. Like in general in physics, there's two things. There's quantities at a point, and there's quantities between points. Quantities at a point are more precise, but they're harder to visualize or measure. Quantities between points are easier to visualize and measure, but they're less precise. We're starting with the latter. We're starting with the concept of how fast. So I'm really trying to say, if I know for a fact that you ran 30 miles to the north in 1 hour, then I know that for that hour, on average, your velocity was positive 30 miles per hour. I don't know how fast you were going at any moment. That we'll get to next. But what I know, or any instant, but what I know is on average, your velocity was positive 30 miles per hour. So number one, I'm saying it's average. Number two, I'm saying this is a definition. The reason I want you to believe this equation, I want you to see that I didn't just pull it out of my, like, believe it in the same way that you believe, or understand it in the same way you understand that a square is a four-sided figure with four right angles and four equal sides. Like, that's not like, that's just like a abbreviation. And number three, and now I will move back to the homework. I apologize for this long. I know this was very long. But number three, the reason I'm saying all this now, like now it's fair game, like now we have an equation to use. It's a definition. So this would be an example anytime you're doing homework right now, like if you're redoing homework 1 or you're doing homework 2, this would be fair game, and in fact, necessary game to be writing down for any step 3 GDP. Like, one thing I started seeing in the homeworks, I want to be clear, step 3 is super important. You'll see it's hard at first, but it's super important when you're doing solving physics problems. Once you write out the question, you got to say, like, what's the concept that I'm using before what do I know that's true even before this problem started? So what do we count as truths? What do we count as legitimate step 3 GDPs in this class? As we proceed, what we'll count is anything that has ever come up in this class. I mean, there's lots of things that are true in the universe, and there's lots of things that are true on the internet, but you're allowed to use all those things, but I can't expect you to know, or like to know which of those things is relevant to our class or not. So from here on in, when you're writing a GDP, you want to write something down that you know is true, like from the class, either from a sheet that said it or that we talked about in the room. So this is a legitimate GDP. Honestly, it's kind of the only GDP in a real way that we really have for a moment, for like homework 2. It's really the only knowledge for all of homework 2. Whether you write it down as an equation like this, average velocity equals displacement per time, or you write in English like average speed equals distance over time, that's actually the only real definitions or hard knowledge we have, or therefore need, for homework 2. Okay, that was a lot. I'm going to go back now. That was all a sidebar. I apologize. I see a question in the chat. Okay, I'm going to get I know sidebars are confusing, so let me just like go back and make it clear that all of that was to do. So that was all just me talking. But as far as what you would want to do for me, back to part 3, question 1 of homework 1. So it was question 1, continue. I'm going to say right now, and then I'm going to look at I see there's something in the chat, but I'm just going to say right now that my GDP, the one thing I know, the one concept I need to answer this question, remember the question, the question was at t equals 7, what is x? Okay, so I don't know how to do that yet. Like I mean, I do, and I'm about to look in the chat. But like I'm doing this homework. I've never seen physics before. I'm a smart person, but I've like never seen any of this before. So the question asked me like, where is he at the 7th second? I might think in my mind, like, do we have a formula, or do we have something that that tells us how to predict a place if we know the time? Well, we might want that, but we don't have that yet. All we know in this class right now, all we know that's at all relevant to that, is how to get average velocity if you know a full displacement in a full time. So I write that down. Like, I might not know what to do with it yet. That will come in step 4. I might not see where this is going. I might think I have no idea, or that I'm missing some equation that I need. But no, this is the equation I have that's relevant. So I write it down, and we'll see what I can do with it. But I'm going to in step 4. But I'm going to pause because there's something in the chat. So, great question. Great question. Wait, okay. So I'm not going to say the name, but question in the direct chat. Is GDP our own definition plus the application we have to use? Great question. I'm going to say not exactly. So GDP stands for general definition or principle. So really the GDP would be actually a definition. Like, so let me start by this. In step 2, WIQ, yeah, I really want your words. I give you a question. I want you to phrase it your way to make clear that you know the question in step 2. But in step 3, no, actually, I don't want your words so much in step 3, especially if there's an equation for it. In step 3, I want the actual like this is an equation. It's a triple equal sign because it's not an equation we discovered, it's an equation we defined. So I literally want you to write that down. Like it doesn't have to be your words, like the actual equation for step 3. And then when you say plus the application we have to use, I think I know what you mean by that, but I think that's really now going to be step 4, if that makes sense. And you could tell me in the chat or not if I've answered your question. But I believe this is what I'm looking for here for step 3, just like this concept that I believe is true.
So can we write, so I see that you wrote the definition of velocity as an equation form. Can we also write it in a sentence as well? Or can we just write both just to make?
Oh, sorry. So sure. Yeah. Especially at this stage, if you're, yeah. And I'll only be happy. Right. If you also like explain it a little bit your way or in your words, or you write it both, the equation, then you show that you actually get the equation in your words. Yeah, that's only even better. Sure.
Okay.
That's great. Yeah. That's great. Sorry, Annie.
Yes, so my question is kind of similar. So for step 3, like if I have that equation down, but I want to like modify it to fit the scenario, like if the question asks like a specific time interval, like what's the velocity, average velocity from like um time equals 5 to time equals 8, can I modify the equation into like v subscript like t like from 5 to 8, and then the x would just be like x of 8 minus x of 5, and then the t on the bottom would be 8 minus 5. Like would that be considered a part of um part 3 general definition principle or part 4?
Great question. Great question. My biggest and I do see what you're saying. To be safest, I would say that once it's getting specific, basically, I want to say step 4. Step 4. Like I see where you're going, and that's like a subtle area. And by the way, I'm also, because I do see that, I think it's great that you're doing that. Like, in other words, okay. So basically, I'm saying step 4. Like for sure, once we're rearranging the question, for sure we're into step 4. I know that you're not saying that. I know that you're saying, and I know that, and also, sorry, to everybody. Number 1, once you start rearranging the equation, which is going to happen all the time, we're already in step 4. Number 2, everybody, once you start plugging in values that are particular to the problem, for sure we're into step 4. Now, Annie's thing is like slightly more subtle. I understand she's not even like plugging in the values yet or rearranging, but she's kind of like assigning the values. She's saying like, okay, the average velocity for this interval, like from for now is where you are this minus where you are there for this particular time interval of then to now. Like it's a subtle thing, but I would say even that you're into step, you should definitely do that. I'm not saying don't do it. It's great that you're doing, but I think it's step 4. And the reason, and of course, all this is like the fact that you guys are even asking these questions means you basically do understand me, which is great. Like obviously we're getting into like details that'll become more clear as we do more examples. But to everybody, the moral of the story of these 2 questions, well, first moral of the story is, please do you all start having more trust, hopefully trust, that these questions really are the class. They are not. Neither of those questions took us away from the class. Like they are the class. Hopefully those 2 people just made things more clear for other people. I believe they did. Second of all, notice I'm about to go back to it now. Don't think that I'm never going to get, like these questions are good is what I'm saying. And of course, more concrete examples will make it more clear. But the big moral of the story is that what step 3 is really supposed to be is some recognizable principle. You want to write it down in a form that actually everybody does know. That's the thing about step 3. Remember all secretly, guys, people, this is practice for exams, but exams are practice for research papers or journal articles, however you want to call, or poster presentations in conferences. And what you're trying to do here is produce a document that makes sense to the physics world. You're trying to produce a document that even if the problem is the first time you've ever seen the problem, like, or even if you already know that I've already seen the problem because like I made it up or whatever, you're trying to turn my artificial problem into like this is how physics analyzes this situation in general. So your step 3, like step 1 and 2 is supposed to be saying to the reader, here's our physics situation we're dealing with. Step 3 is supposed to say to the reader, here's the physics we're using. You know this physics, right? You're with me, reader. This, right? So step 3 is a universal thing. And I'm not assuming your reader is like my dog or my aunt or like my 10-year-old son. I'm not saying any reader. I am assuming your reader is a physics person, but I'm not assuming your reader's in this class. So that's the standard. So step 3 should be instantly recognizable. Okay, I think but great questions. And if I didn't answer, tell me in the chat. I think I did.
Oh, yes, you did. Thank you.
Thank you. Oh, that was another point right there. She totally gets it. That's points right there. Awesome. And if you catch me singing by accident, that's points too. If you catch me singing on key, then that would be a lot of points for both you and me. Okay, wait, so all right. So that's step 3. Now, I know I'm talking a lot. And we have 14 minutes. So I'm going to try to, but okay, so now we've written this down. Now, we've written this down, and I'm literally saying the way I've written this right now, if I were you, or if I'd never seen any of this before, I don't obviously know what to do with it. Like, I don't see the answer in my head for this problem. Actually, I'm me, and I don't see the answer in my head in this problem. I'm just trusting a process here. I'm looking at this now, and now I'm going to sort of do what I think, like Melanie and Annie are saying. I'm going to now say, all right, I think that is the only truth I need, the only general truth I need to solve this problem. It's now time for me to start applying the particular details of this problem. So step 4 is PAW, particular application work. So now I'm going to start rearranging things. The first thing I'm going to do before I even do what Annie was doing, I'm going to say, okay. It's not that I'm looking for average velocity. It's actually that I'm looking for position, right? I'm looking for where is the thing at a certain time. I'm looking for X. So the first thing I'm going to do is rearrange. I'm going to do algebra, right? I'm going to start rearranging this equation so that it's solving for what I want to solve for. Now, of course, all of you have done this a million times. I mean, I know you're all very well versed in like algebra and stuff like that from college, from high school. But so you do the algebra, but notice a couple of things. One big habit in physics is we try to postpone the actual numbers, the actual details as long as possible. We keep, which is going to bother some of you at first. I recognize. But notice, like before I even start getting specific about the numerical values, I'm keeping this general. I'm just like doing algebra because again, like what I'm really trying to do is figure out how to do this kind of physics problem in a way that it doesn't care whether the numbers happen to be 4 and 7 or 8 and 3 or whatever. Like I'm looking for a method that would be generally true in physics. So here, so position equals average velocity times time plus initial position. Notice I'm now into a double equal sign. I am not saying you should memorize. This is not a new equation for you to memorize. It like literally is not a new equation for you to memorize. It's just a result that I'm finding in this context. But I did find it. I think it's true. So now I could say something like, this is now kind of where Annie was going. Okay, let's just go to the next page. So I'm in step 4 now. Now I'm going to apply particular values to this. Now this is going to be subtle. Maybe I should do this in more, and maybe you might take more steps to do what I'm about to do. But if I look at this situation, what are my values? I'm going to say, I'm going to switch screens for a second. well, actually, let me be really clear. The interval, I don't know how to say this clearer, but the interval I'm looking at right now, like we're focused on t equals 7, right? We're trying to figure out where's the thing at t equals 7. T equals 7 is part of that last constant velocity interval. I only want to focus on that last constant velocity interval because, I mean, in mathematical terms, at some point in my math, I'm going to have to like plug in a value for average velocity, right? Well, the average velocity changes 3 times in this. I mean, it changes twice in this problem, right? So if this is going to make any sense at all, I need like a value that I'm going to plug in for average velocity. And like it can't be 3 different values. So I'm picking the interval that I'm in my mind, I'm thinking of the problem in terms of different average velocity intervals. And I want the last one because the last one includes the moment of concern. The moment of concern is t equals 7. So in other words, what I'm saying, so I'm looking at that last interval where someone's here. Sorry. Where he goes from position 4 to position -5. In other words, I'm looking at that last interval for which x naught in the last interval equals position number 4. Okay, which also actually happens to be the initial position for the whole thing. So maybe that, but this all gets back to Melanie's original question, right? Like this is a subtle thing. When I say x naught now, I mean the place where he first was when I first started paying attention to this interval. And I guess really honestly, what I'm saying is this interval starts at what you would otherwise call t equals 5. You know what that may like it's not literally t equals 0 for the whole thing. Wait. Yeah, right? T equals 5. Stop me if that's well, I'll finish it and then we'll see. And maybe this is all we're going to get to in this class, but I think the questions were good, so I think it's okay. So I'm specifically sorry. I'll put this on. In other words, what I'm really trying to say is we are looking at the interval where he goes from 4 to -5 in 3 seconds. In other words, he goes -9 feet, because he's going to the left, -9 feet in 3 seconds. So his average velocity for this interval is -3 feet per second. Where did I get -3? Well, partly I just said it, but partly if you look at your answer for the previous question, I think it was question 6, the thing Melanie was asking about before, it was -3, right? So if I'm just like plugging and chugging now, what I'm really saying is, and then we'll be done. What I'm really saying is, so here, and this is all step 4. Anytime I use the word here, I mean in this particular situation. So you know you're like in step 4 now. Here, then x equals -3 feet per second. Now this is going to be, oh, sorry. And I hold on. I'm going to correct that and you'll see why in a second. Sorry. T equals 2 seconds. That might confuse some of you. I'll explain in 1 second. And x naught equals 4. I'm just going to complete this and I'll answer questions. All right. Looking at the chat. Okay, looking at the time. Okay, so first of all, what I'm saying is the final answer for this problem is -2 feet. So first of all, if you got -2, you're doing something right. You're with me. You may not have written it all exactly this way. It's fine. As long as you wrote it out a way that did all the steps, that's good. This is mostly what I just did for the people that actually didn't quite see how to do this problem. And if there are, we have 5 minutes. I'm going to pause for a second, but I would think if there's anything that's confusing about this is that suddenly I'm putting in like why did I put in 2 seconds for the time? Because I'm trying to emphasize to you that I've now zoomed in. So as far as I'm concerned right now, I'm like a horse with blinders on. The only experiment I'm looking right now is that last bit. So if that last bit started at what we used to call t = 5, and they want to know what's happening at t = 7. So the amount of time that's passed in my focus is from 5 to 7, 2 seconds. Wait, we have, let me just look for 1 second. It would be perfectly reasonable if someone had a question about that right now. And I force you, if you don't, you don't, but you can ask a question. We have 4 minutes. Yeah, I'm going to set up the last one right now so we can finish this home. But feel free to, even if I can't answer it right now, you can flag it. But I think that's how you do the last one. And then for the the second to last one. So then for the very, very last one, I'll try to do it quicker. I'm not going to like diagram, see above. So then what the question is for the very last one is, what's from t = 3 to t = 7. What is that, right? So my GDP is the exact same. The GDP is the same as before. And I don't even have to rearrange it this time. But what I have to realize is, oh, for this one, I need to know the values of X and X naught in this case. But I think I do. And so I'll put the, so this is 1. This is 2. This is 3. And this is 4. Here, I believe X naught equals -2 feet from the problem itself. X equals -2 from above. And T equals 4. So I'm just going to go up here so you don't need a new sheet. So I think V equals -2 minus -2. Sorry, -2 minus -2 all over 4, which is 0 over 4, which is 0 feet per second. I know I just did that quick, but I'm saying the final answer to the final problem on this whole thing is 0. The final answer to this entire problem, I think we have 1 more minute left. The entire sheet, the last question is 0 feet per second. The 2 insights there are, number 1, all you needed was the 2 positions, the final initial position. Well, the initial one was given to you in the original text of the problem, and the final one you just figured out above. So you subtract them and you realize, oh, for this interval I'm looking at, even though he did all this stuff, he went or whatever, he ended up at the same place that he started. So his displacement was 0. So mathematically, 0 over anything is 0. So physically, absolutely, there's a truism that at least one student came up and told me they noticed, which was great. And you could submit that for points. Absolutely, it's a truism from now on that for any round trip you ever do, which in one dimension isn't literally round, a round trip means anytime you end up where you start, no matter how fast you were going, in speed, your average velocity, your displacement will always be 0 if you do a round trip, and your average velocity will always be 0. Even if your average speed is 1,000 miles an hour, your average velocity will always be 0 for any round trip. That's what we're saying here. And there was one other takeaway for this. But yeah, that's the takeaway, that the average velocity for the final answer of this. Oh, the other takeaway is you see how physics problems work. Again, many of you have seen this before. Physics problems classically give you a setup, like one big diagram situation, and ask a bunch of questions, and the questions build on one another. Generally speaking, the questions at the beginning are to establish things that you need later on. So generally speak, don't think there's always trick questions. I see it's 12:05. Generally speaking, questions at the beginning are directing your attention to facts you need to ultimately build to whatever sort of the grand conclusion or the unexpected answer of the whole thing is. That's a classic physics style in homeworks and exams. So I'm going to thank you guys. Have been great, great, great. We're totally where we need to be. You can go, or you can say goodbye and go. I will hang out for a couple minutes if there's any questions. The other class is coming in, so and you can make appointments. And blah, 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 blah. But thank you very much. I will see you. I'm going to turn off the recording and answer any questions, but I'll see you 2 days.